Most people don't know the real story of Alfred Nobel.
One morning in 1888, Alfred Nobel sat down to read the newspaper in his conservatory. He scanned the pages casually, but then he froze. The merchant of death is dead. Dr. Alfred Nobel, who became rich by finding ways to kill more people faster than ever before, died yesterday. It was his own obituary. The newspaper had made a mistake. Alfred's older brother Ludwig had died in France, and the journalists had confused the two. But in that moment, he saw exactly how the world would remember him. Not as an inventor, but as a butcher. Now, the wording in the obituary, the merchant of death and all that, well, it's likely been exaggerated over the years. We could only find an obituary that described him as a man who can hardly be passed off as a benefactor of humanity. But reading this allowed Alfred to see what others truly thought of him, and it wasn't good. He had earned his reputation building an empire on one substance: nitroglycerin. It's one of the most powerful explosives in the world. Its blast pressure is over 100 times greater than gunpowder.
Oh my god. Woo! Oh, that's so sick!
But that power comes at a price. Nitroglycerin is so sensitive that if it's dropped, shaken, or even just bumped, it can detonate.
And as a result, hundreds of workers died trying to handle it. So Alfred made it his mission to tame this beast. But in doing so, he created powerful new explosives used in everything from blasting tunnels to making bombs. Tools that transformed the modern world, but also contributed to deaths of tens of thousands of people, unleashing a level of destruction that would come to define him. Alfred's father, Emanuel, was also an inventor. He opened the first ever rubber factory in Sweden and invented the rotary lathe, which made modern plywood possible. But Emanuel struggled with business. He went bankrupt shortly after Alfred was born. So Emanuel set off to Russia to start over, leaving his family behind. Some of Alfred's earliest memories were of watching his brothers sell matches on the street corners of Stockholm just to afford food. He was often sick, bedridden with colds, stomach problems, and bouts of depression. He would later say, "Mine was a pitiful half-life which ought to have been extinguished by some compassionate doctor as I yelled my way into the world." But soon after Alfred turned 9, a letter arrived from his father asking the family to join him in St. Petersburg. See, in the early 1850s, the great powers of Europe were gearing up for war, and Emanuel spotted an opportunity. He realized Russia's capital was vulnerable to attack from the sea, so he approached Tsar Nicholas I with plans for a new kind of explosive device, one that would float in the harbor and detonate on contact with enemy ships: a sea mine. Within months of his proposal, in the Black Sea just off Sinop, the Russian Navy sank an Ottoman fleet, and the Crimean War began. Emanuel's invention was suddenly in high demand, and the newly established Nobel Armaments factory quickly grew from a few dozen employees to over 1,000, producing mines, torpedoes, and other explosives for the Russian military. With money now pouring in, Emanuel decided to invest in Alfred's education. At the age of 17, Alfred found himself in a lab in Paris studying under the world's greatest chemists. And it's here that he met an Italian doctor named Ascanio Sobrero, who had a peculiar demonstration. Sobrero would take an ordinary-looking piece of cotton and lay it on an anvil. He would raise his hammer and...
It's like a bird ran into a window.
Right? That was a good one, right?
Yeah, that was a great one.
Soaked into that cotton was a new explosive material, nitroglycerin, and it was unlike anything the world had ever seen before.
See, until then, the most commonly used explosive was gunpowder, but it had a major drawback.
It's fast, but it's not that fast. When we were doing it, it was much slower than the speed of sound.
Jesus!
That's because all the ingredients you need, the carbon for fuel, the potassium nitrate for oxygen, and the sulfur to speed up the reaction, they are all in separate grains, and if they're spread far apart, their reaction is just too slow.
Come on, you can do it. Go!
But if you contain gunpowder, that forces these reactants closer together, and it also traps in heat, which accelerates the reaction. And this allows the pressure from the hot gases to build up until...
Well, you see the explosion and then the powder burst out and then it catches flame.
Yeah, you can see the whole bottom comes out and it just catches up to it.
All these particles have to be in close proximity, and they also have to be small enough, and they have to be mixed well enough to get this reaction. So it kind of feels a little bit clunky, like it's not the ideal way you'd want to do this, where it's like all the molecules are actually like right next to each other.
That's a great instinct, putting all the molecules beside each other so that you have them all available to react as quickly as possible. But I think I can one-up that, and that is, can you put everything you need in the same molecule?
Okay.
And that's what nitroglycerin does.
No way.
Yeah.
Okay.
Right? Pretty cool.
That is way cooler.
And because of that, it's way more powerful. We've loaded 15 grams of gunpowder and 15 grams of nitroglycerin into test tubes, and then set them in clay blocks so we can compare their destructive power.
This is a bikini gauge for measuring blast overpressure. And it's called the bikini gauge in reference to the Bikini Atoll because an analog blast overpressure measurement device was used in the nuclear tests in the Bikini Atoll. It has a number of different diameter holes and a film inside.
The larger circles have more area, and so under the same pressure, they will experience more force and so burst first. The smaller circles take more pressure to break because they've got smaller area.
The smaller the circle that gets punctured means the higher the blast overpressure.
Okay, black powder into clay.
Fire in the hole! 3, 2, 1. Yeah, it launched the block a bit, popped the top right off.
Let's look at the bikini gauge, which looks totally intact.
Looks totally intact.
Yeah. I mean, I'm getting nothing, yeah. All right.
Right, so we'll
see if
leave that for the nitro. When the nitroglycerin goes off, it's gonna be like someone shooting a 50 cal. So I don't know if you've been to the range, but that's gonna be a big blast. Fire in the hole! 5, 4, 3, 2, 1.
Oh my God. So first thing I notice is there are bits of clay that have just rained down on me. I got bits of blue all over me.
That's crazy. Right there.
Is there anything left?
Yeah, there's a bunch of clay. On this window, on that window, on this window, on the bikini gauge.
It's like a Jackson Pollock painting.
There's no way we got a frame there. There's just instant light, just
Yeah. When it's fast on the Phantom, then it's fast, right?
Nitroglycerin is incredibly powerful, and it gets this power from its molecular structure. See, nitroglycerin is a highly unstable molecule. It consists of a chain of 3 carbon atoms with 3 oxygens, and then 3 nitro groups attached to those, which are just nitrogen atoms bonded to 2 oxygen atoms. These nitro groups are what makes nitroglycerin so unstable. Oxygen is more electronegative than nitrogen, so these 2 oxygen atoms pull on the electrons from the nitrogen, which shifts the electron density away from this 3rd oxygen. But now there's little shared electron density between these 2 atoms, which results in a much weaker bond between the nitro groups and the main chain. So you get these weak spots, and all it takes is a little bit of energy, like from the shock created by a hammer strike, and then those bonds snap apart. So now you've got all these atoms that are swapping partners, and they form much more stable products, like nitrogen gas, carbon dioxide, and water vapor. And this process releases a huge amount of energy and heat, and it shoots off the products at high velocities. So then these go on to hit other nitroglycerin molecules, which causes their bonds to break. And if this happens for enough molecules at once, well, it sets off a chain reaction.
Now you've got a shockwave, and now it's going to propagate, and as it propagates through, it's going to break bonds here, 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 here.
Its blast pressure is over 100 times greater than the peak pressures that are produced by gunpowder.
Lots of things will explode. Even, you pop a balloon and that's an explosion.
Yes.
But the specific kind of explosion we're interested in with nitroglycerin is a detonation. And the detonation is that chemical decomposition that happens faster than the speed of sound in the material.
What we see in our experiments with nitroglycerin is all these things happen really fast, like less than 100 femtoseconds fast.
I don't operate in femtoseconds very frequently. How fast is that?
Well, femtoseconds 10 to the negative 15 seconds.
That's crazy. So a molecule of nitroglycerin will decompose 3 trillion times faster than the blink of an eye. And it's this speed that is one of the defining characteristics of high explosives.
Yet Sobrero never set out to discover an explosive. He was searching for a medicine to improve blood flow.
During one test, he mixed glycerol with nitric and sulfuric acid, when suddenly it exploded. Sobrero survived, but shards of glass left permanent scars on his face. Deeply shaken, he concluded this new substance, nitroglycerin, was just too dangerous. He later wrote, "I am almost ashamed to admit to be its discoverer." But Alfred disagreed. To him, the hammer strike was like a pistol shot. It was like somebody had kicked open the door to his mind.
It's a real shift in his character because he's been this frail, sickly boy, kind of has trouble with people, and then he discovers explosives and chemistry and changes. You know, it's like whenever he's working, he finally isn't depressed. You know, he can kind of escape through his work.
And you know, at that age, you're probably not thinking about all the possible consequences of this. You're just sort of excited about what it can do.
Far from fearing its power, he believed he'd be the one to unlock it and solve one of nitroglycerin's greatest problems.
If I had a jar sitting right here and I wanted to detonate it, how do I do that?
Need a long fuse.
But what's crazy about nitroglycerin is that a regular flame won't cause it to ignite. So even if I ran a fuse into that vial, it's not going to explode.
See, while a fuse can heat nitroglycerin, which makes its molecules vibrate faster, and it might even break a few NO bonds, it usually doesn't break enough of them at the same time to detonate the rest of the liquid. So it doesn't explode. However, if you drop it, but even that effect isn't consistent. We tried putting a vial loose in the back of this RC truck, expecting the bumpy ride to trigger it. And nothing.
It always seems to be blowing up when you don't want it to, and you can't really get it to blow up when you want it to.
That's very paradoxical.
You know, my browser used to look like a blast site too. I had windows and tabs scattered like debris. I had YouTube, Wikipedia, random research articles. Some things that I swear I never opened. But that changed when I switched to today's video sponsor, Opera. With its free built-in AI tool, Aria, I can use the quick shortcut to write a prompt, and then the chaos is gone. I can say, close all my YouTube tabs, and it's done. Or I can say, group my chemistry papers, and it creates this tab island. I can even hover one tab over another tab, boom, another island. I can expand and collapse them as needed to save space and stay organized. I also love that I can ask Aria anything while researching, like what year did Alfred Nobel patent dynamite in England? And I get the answer instantly without having to switch tabs. It's really helpful when Derek is patiently waiting for the next version of my script. If I'm going through an article and want to take notes, I can just drag one tab down, split the screen, and now I can do both. No need for multiple browser windows. And if I feel like listening to some music in the background, Opera's got a floating music player built into the sidebar. It makes controlling my music easy. I can access my favorite streaming service from anywhere, even while leaving the browser. So if you want a browser that helps you get stuff done, try Opera for free by clicking the link in our description. Thanks to Opera for sponsoring this video, and now, back to some explosions.
In 1852, when Alfred returned to Russia, he moved into a cramped apartment with his brother Robert, and he turned their kitchen into a makeshift lab. He was searching for a reliable way to detonate nitroglycerin, dreaming it could one day power his father's sea mines. But when the Crimean War ended in 1856, the Russian government refused to honor the contracts they'd signed during the war. So the Nobel factory was forced to shut down, and Emanuel went bankrupt for the second time. Alfred later wrote that his father was, quote, a man of genius, but a failure all the same.
And so Alfred goes back to Sweden and he decides, he's like, I'm not gonna make the mistakes of my father. Where does his mind go? Sticking with nitroglycerin. He's like, if I can make this, you know, I'll be successful on my own terms.
By the summer of 1862, a 28-year-old Alfred thought he was onto something. Excited, he gathered his brothers by the banks of Lake Mälaren, just behind his workshop in Stockholm, and he pulled out a metal tube with a fuse extending from the top. He ignited it and tossed it into the water.
That's crazy.
He had finally found a way to reliably detonate nitroglycerin. In its finished form, it works something like this. Alfred took a container of nitroglycerin and inserted a wooden plug and packed it with gunpowder. Then when the fuse was lit, the gunpowder inside would explode, blasting down into the container. And it was that sudden impact that delivered the shock needed to detonate the nitroglycerin. It was just like the hammer striking the anvil.
We need a blasting cap for this.
All right, so now Jesse's gonna add a blasting cap, Alfred Nobel's first major invention. I could just, my heart is just racing more than usual. And I know that it's safe, but yeah, I actually didn't really expect to feel this nervous about it.
Fire in the hole! Fire in the hole! Fire in the hole! 5, 4, 3, 2, 1. Oh my God. Stay down.
Oh yeah, okay. Gotta stay down. Okay, gotta clear the range.
All clear!
Oh my God.
All right, Henry.
Yeah,
how do you like that?
Jeez, man.
Is that what you came for?
Yeah, for sure. That was insane.
Look at how it carved out the exact imprint of the bottle, 1.5 feet below. Okay, look, we even have puncture on the second to last hole. The smallest is not punctured.
Yeah, wow.
So, I mean, that's the entire range of our measurement capability.
I'm gonna get you through there. That's awesome.
His invention, the blasting cap, was refined to use an even more consistent explosive than gunpowder, mercury fulminate. It became the first reliable way to detonate nitroglycerin on command. The design was so effective it remained virtually unchanged for decades.
I think it'd be hard to argue that this advancement doesn't find its place into every other explosive device that comes after it, basically.
Probably the most significant development since the invention of gunpowder.
The same idea, using a small explosion to trigger a much larger one, would later be used in atomic bombs to set off nuclear chain reactions.
With the invention of the blasting cap, the use of nitroglycerin finally became practical.
It can break rock and make tunnels much more effectively.
Nitroglycerin sped up industrial excavation dramatically. In one mine, the rate of tunneling almost doubled from 0.76 to 1.34 meters per day. And in Mexico, crews reported that 15 men using nitroglycerin could do the work of 25 with gunpowder. So orders started pouring in from mining companies, engineers, and railway builders from around the world. To meet the sudden demand, Alfred began producing nitroglycerin in Sweden, enlisting the help of his younger brother Emil. But on the 3rd of September 1864, an intern asked Emil for help moving a heavy crate. The two began to lift when suddenly the factory was ripped apart. A witness wrote this of the explosion. Most ghastly was the sight of the mutilated corpses strewn on the ground. Not only had their clothes been torn off, but on some, the head was missing and the flesh ripped off the bones. These formless masses of flesh and bone bore little or no resemblance to a human body. Emil, just 21 years old, and 4 others, the intern, a janitor, a young laborer, and a passing carpenter, all died in the explosion. Alfred blamed himself, and he swore, "I will never let this happen again. I will make nitroglycerin safe." The city of Stockholm declared nitroglycerin too dangerous and banned its production within city limits. Alfred, however, refused to give up.
And so this is a moment where he's actually a pretty savvy entrepreneur. He says, okay, if I'm not gonna do it on land, I'm gonna do it on the water.
So he set up a laboratory on a floating barge on Lake Mälaren. But as he was experimenting, another one of his factories in Germany exploded. Alfred was fighting a ticking clock. With every day that passed, more lives were lost.
Workers were terrified. No sane agent would use it, a mining publication reported. We confidently expect within 30 days to announce another serious accident.
See, he had addressed the problem of detonation, but not nitroglycerin's fundamental sensitivity. Because nitroglycerin is so viscous, tiny bubbles of air and water vapor easily get trapped inside. As we zoom in, you'll notice there are even more. These gases are a problem. When a shockwave reaches a bubble, it squeezes it, compressing the gas and heating it up. And it happens so fast that the heat can't escape, and so the temperature inside can increase by thousands of degrees Celsius in an instant. It creates a hotspot. The gas molecules in these hotspots carry so much energy that they break the weak NO bonds in the nitroglycerin molecules nearby. And so these molecules then decompose, releasing even more hot gases. But nitroglycerin doesn't just have one of these bubbles. No, it's filled with them. So that's what makes it so sensitive to shock. A single impact can collapse many bubbles at once, which releases enough energy to trigger the chain reaction that detonates the entire liquid. Now, you might think to make nitroglycerin safe, Alfred just has to get rid of those bubbles, right? Well, it's not that easy.
You have an air bubble trapped in it. It's like really hard to get that out without like starting to bang on it, and then you don't want to do that because you don't want it to go off.
But even if you could remove every single bubble, you would still have a problem. That's because nitroglycerin is a lot like the liquid in this beer bottle. I replaced it with water and you can see, there aren't many bubbles. But if I give it a smack, the impact drives the bottom of the beer bottle down faster than the liquid can follow, which creates this sudden pressure drop. And that drop vaporizes the liquid and creates bubbles. When the liquid rushes back in, those bubbles then collapse violently. And those implosions sometimes release enough energy to crack the glass. Now, a similar thing can happen in nitroglycerin. A strong impact can create new bubbles inside the liquid in a process called cavitation. And their collapse again triggers the same chain reaction.
So Alfred realized that the only way around the bubble problem was to change the state of nitroglycerin from a liquid to a solid. Working on his barge in Germany, he tried mixing in powdered charcoal, sand, wood shavings, brick dust, and cement. But nothing really worked. Dejected, he looked down and noticed something strange, a fine powder wisping around his feet. So he looked up and saw the same pale threads drifting over the banks of the Elbe. Millions of years earlier, that dust had actually been living organisms. Diatoms, single-celled algae that once floated in ancient seas. But now, in the dunes above the river, all that remained were their fossilized exoskeletons. That made for a fine silica powder that carried on the wind. This material, diatomaceous earth, or kieselguhr, had been appreciated by Darwin. He wrote, "Few objects are more beautiful than the minute, silicious cases of the diatomaceae." But Alfred saw beyond their beauty to the microscopic holes in their exoskeletons.
On the granular level, it's got lots of little pores and places to absorb the liquid into.
We're looking for what kind of consistency?
Oh, it's going to be like thick and solid. It will make the nitroglycerin less sensitive, so the same hammer impact that you would try with straight nitroglycerin would take more force because that absorbent material will take some of that energy from the impact.
That just kind of feels like we're baking.
Right?
In fact, kieselguhr can soak up more than 3 times its weight in liquid nitroglycerin.
And so if it's porous, now if you mix it with the nitroglycerin can kind of go into the pores. What that helps do is separate the nitroglycerin molecules from each other.
And within any individual pore, there just isn't enough nitroglycerin to propagate the detonation. So now when it's bumped or shaken, the mixture won't detonate. And if we drop it in the exact same way that set off the nitroglycerin,
Drop.
It didn't go.
No.
So this new material won't explode when you drop it. So can you still detonate it? Well, if you combine it with Alfred's other invention, the blasting cap, the resulting shockwave is powerful enough to compress many pockets of nitroglycerin at the same time, which triggers the detonation.
The biggest explosion we've seen up to now is 100 grams of nitroglycerin.
Yeah, that'll be the biggest one we've done so far. 3, 2, 1.
Oh, that's so sick!
To all whom it may concern, be it known that I, Alfred Nobel, have invented a new and useful composition of matter, to wit, an explosive powder. To name it, he took the Greek word dynamis, meaning power, and he made it dynamite.
Alfred was determined to capitalize on his new invention, and he believed that he could make the most money in England. England is a jewel worth the rest of the world, he said. A dynamite company there would have the entire empire as its market. So in the spring of 1868, he set foot on British soil, carrying with him a suitcase overflowing with dynamite.
Because he's going around and he's inviting journalists to come to these demonstrations where he would bring sticks of dynamite in his backpack and a stand. He would set up these huge boulders basically and put a stick of dynamite in there and watch as they cleft in two. Alfred was a clever salesman. So when Alfred created dynamite, nitroglycerin still had a terrible reputation. And so his initial thought was to name it Nobel's safety powder.
Oh, I like that.
Come on down and get your Nobel safety powder and blow the hell out of this rock. You know?
Whatever the name, his invention came at the perfect time. Around when Alfred introduced dynamite, there were two other major breakthroughs: the pneumatic drill and the diamond drilling crown, which now made it easy to bore holes in solid rock, perfect for a stick of dynamite. These tools revolutionized construction. Many of the iconic engineering feats of the era, from the Brooklyn Bridge to the Panama Canal, depended on dynamite.
One thing that I think is really interesting to think about is Russia, at the time, isn't the Russia that we think of now. It was effectively a mid-sized European country because they had this vast wealth of resources, but it was cut off by these mountains. And so without dynamite, you actually wouldn't have the Russia we have today because you would have never been able to make the Trans-Siberian Railroad. It's worth saying that dynamite is different than TNT.
Yeah, I was going to ask about that actually. Trinitroglycerin.
Trinitrotoluene.
Trinitrotoluene.
Yep, trinitrotoluene.
Those nitrogens are bound to carbons, not to oxygens. And so that makes it much more stable, so you don't have that really weak oxygen-nitrogen bond. Because of that, it is much, much, much less sensitive than nitroglycerin.
So that actually wouldn't be discovered for another couple decades after dynamite?
The TNT labels on the dynamite sticks in the Looney Tunes cartoons never bothered me when I watched them as a kid, but now I'm just like, wait, that's not right. They're not TNT in there.
But the main point is that dynamite happened first, and no matter what AC/DC says, it is not TNT.
It's a good line.
Yeah, I mean, it's a good track too. So dynamite was changing the world, but the old dangers of nitroglycerin were hard to escape. In 1869, near Brentford, England, a barge carrying dynamite exploded on the River Thames, killing 3 people and damaging buildings 800 meters away. Investigators traced the cause to dynamite that had been sweating beads of nitroglycerin. See, wet kieselguhr from the riverbed has to first be dried to remove moisture, and that leaves empty pores ready to absorb nitroglycerin. But the kieselguhr never loses that strong attraction to water. So if your dynamite is later exposed to moisture, even just humidity in the air, well, water seeps back into those pores. And the invading water molecules then encounter nitroglycerin, which gets pushed outwards. Now, moisture wasn't the only culprit. Time and temperature could also cause this separation, but moisture just made the problem a lot worse, though it actually wasn't Alfred's only concern. See, kieselguhr is inert, and since dynamite was about 25% kieselguhr, that meant it would always absorb a large fraction of the explosive energy, and that power was wasted. It reduced the strength of Alfred's explosive, and ultimately it hurt his bottom line.
So he kept experimenting with new formulations and new absorbents. Again and again he failed, but he was undeterred, saying, "If I have 1,000 ideas and only one turns out to be good, I am satisfied." Then one day, while working in his home lab in Paris, he cut his hand. It was a pretty deep cut and blood started to pour out. So he grabbed a bandage, pressed it to the wound, and watched it soak up the mess. That night, the pain woke him. But as he was lying there in the dark, annoyed at his earlier carelessness, his mind drifted back to the bandage, how clean it was, how fast it absorbed the blood. He bolted upright and rushed down to the lab. He thought, if cotton is so good at absorbing blood, maybe it'll be just as good at absorbing nitroglycerin.
So inside that bandage is this, and it looks like regular cotton, but you'll see it's not when I light it up. Woo!
I remember, watching this YouTube video where they just light it on fire and the whole thing's just gone. Yeah. And it is so counterintuitive and so just crazy to see. It's like magic. I'm sure it's used in like magic shows too.
Yeah. It's called gun cotton, or nitrocellulose. And nitrocellulose is made by taking cellulose polymers, say from cotton or wood pulp, and then replacing the OH groups with oxygen atoms bonded to nitro groups, which are the same unstable groups that made nitroglycerin so explosive. So now when you ignite it, these groups rapidly break down into products like nitrogen, carbon dioxide, and water, all of which are gases, so there's no particulate to scatter light. That's why the whole thing seems to just disappear into thin air. But what Alfred was interested in was what happened when you combined it with nitroglycerin. See, nitrocellulose has these chains that are very similar to nitroglycerin chemically because of the nitro groups. So because of that, they mix easily.
Now you have two things that are soluble. They like each other. This is very different from, Kieselguhr water and nitroglycerin.
And now, when you mix them, the smaller nitroglycerin molecules slip between these long nitrocellulose chains, trapping the nitroglycerin molecules and keeping them apart, just like in the dynamite. If you mix in just a small amount of nitrocellulose, you get a stable, moldable gel that resists sweating.
We're gonna take a little bit of the nitrocellulose, the gun cotton, like this much.
Yeah.
Okay, we're gonna start with a little bit. We're gonna drop it in there.
You see that it soaks right in.
Yeah. Keep on adding bits until
it soaks all up, and then we'll stir it around to make sure there's no dry spots.
But that's not all. This mixture also solves Alfred's problem of yield. The matrix, the structure that it's being held in, is itself explosive. So now you get perfect yield, no sweating, bing bang boom. And because the material is a gel, it can be molded into different shapes, perfect for precise, controlled mining blasts.
While it's soft like this, we can put it into a shape, and then when it sets, it'll stay that shape.
Do we got enough to do a VE?
Oh yeah. Let's make a VE.
Alfred named it Gelignite, the world's first moldable explosive.
With gelignite, dynamite, and the blasting cap in hand, Alfred had fulfilled his oath. He had made explosives safer for everyone.
He opened factories across the world, in Scotland, France, the United States, and beyond. By the early 1870s, he was running more than 90 sites in 20 countries. But not everyone was happy. His father never recovered from Emil's death, and just weeks after the explosion in Stockholm, Emanuel suffered a stroke. He survived, but was never the same. Emanuel became obsessed with death, often rambling to Alfred about strange inventions, including a scheme to build a network of underground tubes that would carry corpses directly from people's homes to giant incinerators.
His dad never had the success that Alfred's having, financially, and he's being lauded as this great inventor. His dad, I think, is just jealous, essentially, but he claims that Alfred had stolen the idea for dynamite from him.
So he says to his dad, "Rather than regarding this idea as your own, far from it. You laughed at it. Your fatherly love seems to run aground on complacency or vanity. It should not seem strange that I, at the age of 30, will not allow myself to be treated as a schoolboy. It pains me, but when it comes to serious matters, I've adopted the rule of acting seriously." Despite the confident front he put up for his father, the truth was that his wealth hadn't made him any happier. He says, "I'm 2 steps ahead of my competitors, but the accumulation of money and praise leaves me totally indifferent. My home is where I work, and I work everywhere. I am a nomadic atom, with no attachments, no roots, and no real joy in life." By 1876, he couldn't take it anymore. Overwhelmed by the loneliness, he placed an ad. "Wealthy, highly educated elderly gentleman seeks lady of mature age, versed in languages, as secretary and supervisor of household." And into his life entered Bertha Kinsky. She was an idealistic woman, part of the budding peace movement. Together, they took long carriage rides where they discussed the role of science in society and whether it could serve a purpose greater than war. For a moment, Alfred was happy. Hopeful, he asked if her heart was free. But while Alfred was away on business, she left to be with another man in Austria. So Alfred was back to being alone.
Alfred was heartbroken. He responded by throwing himself even deeper into his work.
Alfred attempted to sell his explosives to the French military, but they weren't interested. Then a year later, when war broke out between France and Prussia, German troops hurled dynamite at the French positions. Now, Alfred received a message. The French wanted to place an order.
One thing that I think is important to think about in this moment is that people have been stabbed, bruised, shot with gunpowder, and all this other stuff. But up till then, it would have been totally foreign to see that level of destruction on a human body.
It would have been unmatched in kind of human history.
As he starts thinking more about war and becoming involved with the French military, the German military, the Italian military, they come to him with a problem that's been plaguing them for hundreds of years since the invention of gunpowder, which is that on a battlefield with black powder, when you shoot, it obscures visibility, so you don't really know how to shoot again. You can't aim very well.
Yeah, one thing you're seeing with the black powder is that every time it explodes, there's just this huge plume of smoke that enemy fighters would be able to see your location.
So it's just this big problem where there's a literal fog of war. Alfred starts contemplating that problem. What he thinks back to is gun cotton. It doesn't create smoke. Can I use gun cotton to replace powder? But the problem with using gun cotton, or any high explosive mass, in small arms is that it detonates all at once, releasing its energy in a split second. And the pressure inside the barrel spikes faster than the bullet can accelerate. So much of the energy is wasted as heat. Instead of propelling the projectile, it can even destroy the barrel. What Alfred wanted was a propellant that built pressure gradually, so the force rose smoothly as the bullet traveled down the barrel. So he began experimenting with a new nitroglycerin nitrocellulose mixture. By adding 10 to 20 times more nitrocellulose than in Gelignite, he transformed it from a jelly into a tougher substance, one that could be rolled into pasta-thin sheets. In Italy, they even used pasta makers to do this. These sheets were then stamped into countless tiny little grains. When these grains were packed into a cartridge, they wouldn't fit tightly. Small gaps of air remained between them, but that was actually a good thing. Now, when one grain ignited, a shockwave couldn't just race through the entire charge at once. Instead, each grain had to ignite its neighbor, and the one beside it, and the next one in sequence. This slowed down the burn rate and allowed the pressure to build gradually. So they were able to replicate the effect of gunpowder. And because the fuel was a combination of nitroglycerin and nitrocellulose, both of which broke down into clear, stable gases, it burned with little smoke. So Alfred had solved a problem that had plagued armies for centuries.
And to this day, the propellant in much of the world's ammunition is still a combination of nitroglycerin and nitrocellulose, just like Alfred's invention. He called it Ballistite, the world's first smokeless, high-energy propellant.
Alfred quickly received an order for 300,000 kilograms of ballistite from the Italian army. So he opened a massive armaments factory in Italy and began to fall deeper into the world of warfare.
He developed landmines, early gun silencers, and even experimented with one of the first rocket-powered missiles. It flew over 4 kilometers downrange and allegedly captured this image.
The whole time he's in contact with Bertha, the woman who kind of jilted him, and she's become pretty important in the peace movement at the time. She wrote this book called Lay Down Your Arms that became kind of a sensation and established these peace congresses across the world.
To her, he insisted, "My rockets are meant not only for war, but also for the rescue of shipwrecked persons." He even took it a step further. "Perhaps my factories will put an end to war sooner than your congresses. On the day that 2 army corps can mutually annihilate each other in a second, all civilized nations will surely recoil with horror and disband their troops."
This is a concept that we see a lot of. When people are sure to kill each other with the modern weapons that I've given them, no war will be possible. It's also the same thing that we think about in Oppenheimer.
I feel like we've heard it so many times that you just can't believe it ever.
No.
And then it's just marketing on the part of all these guys who are selling weapons. They don't want to come across as evil guys who are like, I'm going to make something that'll help you kill more people than ever before. I mean, that's kind of the truth of it.
Especially in the dynamite case, it feels like a tremendous misjudgment of human nature. It's like, yeah, this is not going to be used to stop war. And we definitely don't see that in the decades that follow.
Between the 1890s and the 1920s, over 7,000 bombings occurred in New York alone. Imagine waking up, opening the paper, and seeing another explosion every other day for decades. The most common perpetrators were known as the Dynamite Club. They were part of a deadly new political movement on the rise in America. They rejected industrialization and longed for a simpler world. Today, their name evokes chaos and destruction. But at the time, it was more literal. No ruler. Anarchos. This was anarchy.
They were so crazy and so effective using dynamite that Theodore Roosevelt addressed Congress, and he said the largest threat facing the US is the anarchist threat.
Were they intentionally just killing people?
Yeah. Their argument was that, if one person dies at the hands of an anarchist, 100 people have died in the industrial machine. Yeah.
These people sound crazy.
In fact, the entire modern practice of terrorism, using spectacular violence to advance a political agenda, often targeting civilians, well, that all began with the anarchists and their dynamite.
Dynamite unlocked a new scale of destruction previously unimaginable. With only a few sticks in a coat pocket, one person could walk into a crowded street and wreak havoc.
What began as an industrial tool had become a weapon of mass murder.
In 1927, in Bath, Michigan, a man spent months wiring the town's new elementary school with dynamite. He hid the charges in the basement and crawl spaces, concealed them under floors and behind walls, all while serving as the school board treasurer. Then, on the morning of May 18th, just after classes began, he triggered the explosives.
As parents and rescuers rushed to the scene, he arrived in a truck packed with more dynamite and shrapnel and detonated.
In all, 38 children, 6 adults, and the attacker died. Another 58 were grievously injured.
The deadliest school massacre in American history was not a shooting. It was a dynamite attack. Of course, Alfred couldn't know all the ways in which his inventions would be abused, but he had seen the destruction in his own life, and he had heard the pleas to change his ways. So in 1888, when he read that paper, something in him broke.
Just a few years later, as his health began to fail, as he took pellets of nitroglycerin to ease the pain in his chest, he couldn't shake the thought. So he called his lawyer and wrote a new will.
With 94% of his personal fortune, 31.2 million Swedish kroner, or about $340 million today, he created a set of prizes for those who, during the preceding year, shall have conferred the greatest benefit on mankind, the Nobel Prize. There were 5 in total for chemistry, physics, medicine, literature, and finally, peace.
On December 10th, 1896, Alfred Nobel died in his villa in Italy. Just as he had always feared, he died alone. At the time of his death, he held 355 patents and ran an empire of 90 factories that produced explosives and armaments across the world. And yet, in his final act, he gave his fortune away for an idea.
So, did it work? Did it redeem him in the eyes of everyone today?
Have you ever heard the name Alfred Nobel?
Oh yeah, he was the creator of the Nobel Peace Prize.
Nobel Prize. Nobel Prize.
Nobel Prizes?
Nobel Prizes.
Nobel Prizes.
Nobel Prize.
Nobel Prize.
Nobel Prize. Nobel Prize.
Anything else?
I should know more.
The Nobel Prize.
Is that it?
Yes.
I'm saying like nothing like dynamite. Don't think about that at all.
Dynamite.
Yeah. He also invented dynamite.
Did not know that.
I didn't know about the dynamite. I knew about the Peace Prize, but that's it.
I think the attempt has been to have him portrayed as somebody who tried to promote new understanding and advances in science. And so that's
his legacy.
Yeah. It would seem.
I mean, if you're cynical, you say it's a PR move.
And are you inclined to be cynical?
I think It must be at least somewhat a PR move. To me, like, Nobel Prize has always been like the pinnacle of achievement. If anyone wins the Nobel Prize, like, yeah, you're done. Like, that's all you need to accomplish in life. I mean, in some ways, like, maybe he was in control of his legacy.
Yes.
And he took control of his legacy.
He did.
Decided he wanted it to be a positive thing.
There's a twisted irony to this story. When Alfred Nobel created dynamite, he was trying to make explosives safer to prevent the kind of accident that killed his brother. But by making nitroglycerin easier to handle, he also made it more accessible, and that made it more deadly. So why then did he create the Nobel Prizes? Was it out of the goodness of his heart, or a desire to redeem himself in the eyes of everyone who would come after? I mean, I think the idea that anyone anywhere can be recognized for advancing science, literature, or peace is beautiful.
This award is not just a piece of metal that you would wear or an award that you would keep in your room, but this is really an encouragement for me to go forward and to believe in myself, to know that there are people who are supporting me in this campaign.
So maybe it doesn't matter why he did it, only that he did.